I didn't add details to the first 3 parts of the Frankenso soldering videos due to them being in other videos, but because they're spread all over the place, I'll put them all here so you don't have to look for them. Detail number 1. Buying a stencil. I bought a stencil from here, but I assume all the other manufacturers are pretty much the same. Make an account, just click SMT Stencil, quote now, add a Gerber. You can either download the master from the GitHub to get the Gerbers, or the quicker way is go to the Frankenso page in the forum, go down to SVN repository, open that, select Frankenso Gerbers, and download the correct zip for your board. It should be written on the PCB. Navigate to your download. Now on my PCB it says 5.3, so I assume it's this one. Select. It says $8.70 plus $21 registered here, and just select your method of delivery. As an addendum to the bottom side, I'm going to add thermal glue to the side of the big diodes just in case they fall off when they're upside down. These are parts I should have glued to the PCB right from the start, due to them being so big and heavy. I also didn't put any SMD glue under the pot because I was worried of gluing the shaft. So I'm adding a few blobs on the outside now, just in case it falls off. We have our parts set out in I-bomb order and all the parts removed from the Ziploc bags, because we need everything organised and ready to go, because we only have an allowable 2, maybe 3 hour placement time due to the solder paste drying. On a side note, there's about 200 parts on this side of the board, but if you look at the onboard STM32, there's 65 parts. 65 parts is a good incentive not to populate, because it would save a lot of time. I will be fitting as much as I can in case someone needs this section. With double load boards, you've got the problem of it not sitting flat anymore because there's parts underneath, so you're going to have to space it off the table. We don't want our PCB moving, so we have to restrain it somehow, or it'll smudge the paste. Clean it with isopropyl alcohol. Place the stencil so you can't see any red. Tape the stencil in position so it can be lifted up like a hinge. If you want, you can mark the points you don't want to put paste on. Why waste paste? Detail 2. Solder paste. Practically any solder paste works if you use a stencil and only want a connection, which is good enough. But if you want it looking good, there's tricks to it. Low volume solids paste has extra flux in it, so it spreads smooth and is very tacky, but it really needs a thicker stencil to look good. Extremely high volume solids pastes only work with a stencil. The low flux count makes it dry and hard to spread. It gives a fuller looking joint by virtue of its higher volume solids, but it's impossible to manually apply by hand without a stencil because it's not tacky enough. For this side I'll be switching to mechanics, which is a high volume solids paste, but somewhere between the extremes. The mechanic is firmer and not as easy to spread as the chem tools that we used on the bottom side. The other problem was the stencil didn't sit flat on the PCB, so every time you released it, it lifted up. Thankfully the paste was firm and it didn't go under the stencil. I originally went with a very hard scrape of the paste down to the stencil, which as you can see leaves it pretty clean. But I couldn't really tell if all the holes were being filled, so I switched to an even layer over the top. As well as showing better which holes are filled, I figured the thicker paste would leave a fuller joint. This extra thick paste layer did cause problem with the one fine pitch part, but all the rest were fine. I'm going to quickly gloss over things that is a repeat from Frankenso 2, so I'll concentrate on the problems you might have and missing details from the other video. Open the Frankenso I-bomb, select front and go through the list starting at 1. Note the value and the quantity. Grab the top part off the board, check the value, tip out the exact number of parts you'll need. You can count them as they drop just to be sure. I also marked my tape as to how many I'd need. Discard the packaging off the board so you know what's next. Get a 2.5 magnification visor, pick them up and just start placing parts. The biggest problem here is not brushing the board with the palm of your hand and smudging paste and knocking parts off. There's not much else to say about placing passives because as you can see it's pretty straightforward. I fitted 50 capacitors and it took me about half an hour. The important thing with the capacitors are the tantalums and the electrolytic are polarized and can only go in one way. So the line on the part must match the line on the board. The mark on the tantalum signifies the positive side. Electrolytics are also polarized and there is a positive mark on the PCB. But electrolytics are always marked on the negative side, so it's placed on the opposite side. If you search around you'll find a picture. The biggest mistake with capacitors is mixing up picofarads with nanofarads and microfarads. Doesn't help when they use fractions when they could be using whole numbers either, but if you did your job it should be right. There's not much to say about resistors. I fitted 86 resistors and that took about an hour. The only problem I had with resistors is I missed a few pads and had to manually apply some paste. It's not easy applying a dry paste by hand, so I might have to check for shorts under these two parts later. Diode D1004 is straightforward. Just remember to tap parts down so the pins make contact with the paste. D1001 doesn't use the usual diode silkscreen, but there is what looks like a diode symbol at the top, and there is an A which I assume is anode or negative. So the line that signifies positive will be on the other side. LEDs. This was explained in the first Frankenso soldering video, but looking down on the top of an LED, there's two green marks that signify the negative side. So it goes on the opposite side of the marked positive on the PCB. The LEDs were fairly straightforward except for D351, which didn't have a direction marking. The positive non-marked end faces the resistor. D7 was the same, and you can just see the trace running from the diode to the resistor indicating the positive side of the LED. Our last diode is D413, and that's our BAT54, and just match the line to the part line. Check polarity and place 26 diodes, 3/4 of an hour. U1001 is the 5V voltage regulator. U161 is the T-PIC 8101. The mark is on this end. So pin 1 is here. CAN chip U471. TC4427s. These use a dot for pin 1. The joystick button has pins that don't protrude but tuck under, so it's a bit hard to line up. U101 is the VR chip, the MAX 9926. This fine pitch IC had a problem with the extra thick layer of paste and wound up with bridges across the pins. Also, you'll notice this chip is not aligned perfectly and it didn't self-align in the oven. So double check your alignment before it goes in the oven. Q1002 is a MOSFET for the power supply. Q401 to 412 are the VNS 14N MOSFETs, and they have the same conventional silkscreen mark, but the chips don't have the conventional pin 1 mark, and that's where we figured out the ST logo is the pin 1 mark. Keep an eye out for these because the marks could be anywhere. They could be up, they could be down. Q1001 is a P-channel MOSFET for the power supply. The J351 locating pins are hard to line up because you can't see them. Those 28 parts took about half an hour. With filming and double checking the polarity of parts, it took 3 hours to place 190 parts. If you deleted the STM32 parts and the thermocouples, it would probably take about 2 hours. Other parts that didn't come in the kit I'll quickly mention, just in case you want to fit them. D5, 6 and 9 are a BAT60 diode, and you can see the positive polarity marking on D5 and D6, but on D9 it's hidden because it's on the pad of the F1002. Pin 1 of the MAX 31855 chips goes here. These 4 are for the thermocouple circuits. I bought these extra, so I fitted them. There's USB filter U2. Yes, we'll be having to wick some bridges before we power on. The voltage regulator LM2937, which is U3, the STM32 chip U1, the X2 crystal. MC306 seems to have a crystal between pin 1 and 4, and I only see traces to this pad and this pad, so I assume that is the pins. F1002 says it's a fuse, but it's some sort of polarized diode. It is in the IBOM, but in the BOM CSV it says do not populate and no mention of what it is. And J1 USB or J2 for the vertical version. Our board is empty and all the parts are off the board, so that's all our SMD parts fitted. Through-hole parts will be covered later. Next is oven soldering. Detail 3. Oven soldering. Solder pastes have a specific heat profile they should be heated to, and it would be nice to follow that profile, but we should be able to get away with it just by heating it up until we see the solder melt. The only thing you might run into is solder bubbling if you go too fast. So pause before the solder point to dry out the flux. My oven's not that fast, so I'm going from 0 to 180 degrees C solder point in about 12 minutes. I'm using a $10 toaster oven that I bought from a swap meeting. It's best not to use something for food because of the lead in the solder. And a cheap $6 digital thermometer. This is the wire for the thermocouple. You need to place something under the PCB to catch any parts that might fall off. I use this aluminium sheet, but aluminium foil should be good enough. and you can't rest the board on its underside parts in case it bumps them off. You could shape the aluminium foil to hold the corners up, but I use brass screw standoffs. My mechanic paste has 183 degrees C written on it, and the pads with small volumes of paste did turn at around 190 degrees C. But these big pads took 220 degrees C. When I don't have the aluminium plate in there, it turns to solder about 180 degrees C just with the bottom oven element. But it was taking so long I had to switch the top element on as well and take it to 220 degrees C. It took over 15 minutes. It's like the paste has to dry out and turn white before it can turn to solder. Just with a quick inspection, there was bridging on 2 unpopulated footprints. I probably should have cleaned the paste off before it went in the oven, or not even apply it. Either way, it won't be hard to fix with some solder wick. The other problem was too much paste on the only fine pitch part. This won't be hard to fix with some solder wick. The other parts look fine with the thicker paste layer, but I probably should have scraped the stencil harder to reduce the paste thickness just for this one part. The other problem is it's slightly misaligned because it didn't self-center in the oven. You can imagine how hard it would be to remove this to fix it without buying a hot air station. Maybe you could lever one side up at a time with a special tip and hopefully not bend the legs too much. Either way, it's a lot easier to check your alignment before it goes in the oven and get it right the first time. Just for the first timers, I'm using a cheap USB microscope for inspections, but you must get the one with the least magnification. You only ever use between 25 and 40 times magnification, so anything other than a 25 by 200 USB microscope and there won't be enough room under it to do any work. The extra lighting I'm using is just for the camera.